Well, hello there, ladies and gentlemen. We're going to learn about cumulative frequency graphs here. And this is something that's both easy and difficult at the same time. Kind of like not getting in trouble for saying something stupid. Super easy to keep your mouth shut, right? But yet, it's not. Anyway, that's what we're going to do right here. Listen, this is a very hands-on topic, right? A lot of times you have to create these graphs. So watching a video is going to equip you with the ideas, but you're going to have to develop the skills on your own through practice. So here's what we're going to be doing in this video right here. We're going to learn what a cumulative frequency graph is, how to make a cumulative frequency graph from a data table, how to make a data table from a cumulative frequency graph, how to find the median, how to read the graph, how to answer questions about the graph, how to find the interquartile range. Let's get to it. All right, so first of all, cumulative frequency. So accumulation is when you count things as they grow. So, for example, if you want to talk about how much rainfall do we have in a year, well, you add up the rainfall from the first storm to the second, and then when it storms the third time, you add that, and then the fourth, and so on. So if the first storm of the year had 1 inch of rain, and the second storm of the year had 2 inches of rain, well, that would be an accumulation of 3 inches, right? For 1 from the first, 2 from the second, so on. If the third storm had 5 inches, well, then you would have an accumulation of 8. Do you see? All right. Now, so that's what accumulation means. It just adds as we go. So what we're doing with the cumulative frequency graph is we are adding up the frequencies as we work through each of the classes. So if we had something like this, and we are asked to figure out what's the cumulative frequency, what we're doing is we're adding up the frequencies as we work through the classes. Now, on the graph, the classes are still the x-axis. That's super important to keep straight. Most of the mistakes are going to come from this idea right here. The y-axis is cumulative frequency, which is how often something occurred, right? And the x-axis is what it is that has occurred. So it's the classes. It's what it is that you're measuring, and how many times it was measured is frequency. All right, so now look, cumulative frequency. So what we have here is we have 5 people that were, on the graph, these will be described for you right here. These is 120 centimeters to 130 centimeters. So 5 people were taller than 120 centimeters, but shorter than 130, or 130 exactly and less, right? But between 120 and 130, roughly speaking, there were 5 people. Whereas people that were between 130 and 140, there were 8 of them, right? But the cumulative frequency would be 13. So this means, this 13 right here, what it means is there were 13 people that were between 120 and 140. Do you see? So like, for example, there are 58 total frequencies. There are 58 people measured. That means 58 people were 180 centimeters or shorter. That's what this means right here. So when you're talking about cumulative frequency, what you're doing is you're saying, hey, what's the cumulative frequency up to 160? Well, that would be who is between 120. How many people were between 120 and 160? So you just add all of the prior frequencies, right? So you just add them up as you go. Now, if you just do that, but you forget what it means, you're going to get yourself confused. This is a super easy table to fill out. You're just adding all the numbers. But cumulative frequency means that you're adding up the frequencies as you count. So what this 55 means, what this 55 means is that 55 people were 170 centimeters or shorter. That's what this 55 means. The way you get it is, of course, you just add all the frequencies of the people that were shorter than that, and they're all broken down right here. So when you make your graph, this is what it's going to look like. Your y-axis, cumulative frequency. Your x-axis are your classes. Now, a couple things. This curve needs to be smooth. You have these points, you plot them, right? We start at 0, right? We're going to say nobody was less than 120. And then at 130, we had 5 people. We had that 5, we had 8 more, which gives us 13 people that were 140 centimeters or shorter. So you 140 centimeters, there were 13 people that were that or shorter. But all these points in between on this curve, we don't know. We're going to use this curve to estimate. So you need to make sure that this curve is smooth. Don't use a ruler to connect the dots. Make it smooth. They're almost always going to look like this. These graphs are almost always going to look like this, okay? So just to make sure, let's break this down. Look, this last value right here is your total frequency of 58, right? We start at 120 and 0. At 130, we have 5 people. we have 5 people that are 130 or less. Now, we don't know where these 5 people are. They could all be, 121. They could be all 130, exactly. They could be spread out in between. No, we don't really know. So that's what the curve is doing. It's kind of distributing those 5 occurrences evenly between. And we're not exactly sure, but this is going to give us a way to estimate. So now, people that are less than 140 centimeters, 140 or less, there are 13 people. We don't know exactly where they lie. We know that there are 8 of them that are between 130 and 140. But we know that there are 13 between 120 and 140. So that's what these points are helping us do, helping us kind of distribute these frequencies on a graph so that we can read it, right? And that's where all of these coordinates come from. So just to make sure, to recap, the big idea so far, here's what we're saying. See this 160, 48? This is 160 centimeters. So there are 48 people that are 168 centimeters or shorter. 48 people. There are 55 people that are 170 or shorter. Do you see? There are 3 people that are taller than this. And the reason I know that is the frequency is 58. The frequency here is 55. So let's talk about that, right? So just to make sure, the way you find total frequency from a cumulative frequency graph is that last frequency. They get added up. There are 58 total data points. 58, right? All right, now let's talk about reading the graph. Right? So when you're reading the graph, a lot of the time you don't have the frequencies, you just have the graph. So what if you were asked, hey, how many people of these scouts that were measured, there are 58 of them total, how many of them were between 150 and 160 centimeters tall? Well, 150 to 160. So between 150 and 160, well, up to 150 there were 35. Up to 150 centimeters tall, there were 35 people that were 150 or shorter. There are 48 people that are 160 or shorter. So if you want to look at the people that are taller than 150 but shorter than 160, well, that would be the difference of 48 and 35. Do you see? 13 people. That's it. That's all you got to do. Now, that one's easy because those points were given to us. But what if it asked us something a little different? Same kind of a question, same style question, but a little different. So now it says, how many scouts are shorter than 158? How many scouts are shorter than 158? Well, shorter than 158. So remember, these are accumulating as we go. These frequencies are accumulating. So again, just to make sure, there are 35 people that are 150 or shorter. 35 people, 150 or shorter. So if we want to figure out who's shorter than 158, well, we got to go to 158 on our graph, which is right about here. And then we got to see what is the cumulative frequency up to 158. 46 approximately. We don't know for sure that it's 46 because this curve is hand-drawn. We don't have that specific data, but we can approximate. We can estimate based on the graph. So we're going to say that there were 46 people that were shorter than 158 centimeters, which means if we want to figure out how many people were taller, well, we just have to look and we have to say, oh, well, that looks like it's going to be about 12. So we got about 46 that were shorter and about 12 that are taller. See, everybody above this, everybody past this up is taller than 158. Everybody to the right of this is taller than 158, and there were 12 of them. And everybody beneath that, right, that 46, they're all going to be shorter. That's how you read these graphs. All right, now let's talk about the median height. Now, median is the physical middle. So if you arrange all 58 of these people from shortest to tallest, you pick the middle. Well, the middle of 58 is 29, right? So the 29th. So what you're going to do is the way you do this on the graph is you say, well, if there's 58, you divide that by 2, 29. You go to your graph, where's 29, and then you draw your line. You have to use a ruler on this, draw it. A lot of the times, depending on the type of class you're in, they will mark you off if you don't draw it. They'll sometimes give you no credit at all. So use a ruler, draw it nice and neat, do a solid line. I did dotted so it stands out a little bit. But draw a solid line until you hit your curve, and then make sure you go directly vertically down until you get to your x-axis, and then you can see where approximately that height would be. So the median would be the 29th entry, and it looks like that's going to be around 147 centimeters tall. So the 29th person is the median. The median person is the 29th person. How tall they are is 147 centimeters. That's what's being asked. What's the median height? Do you see? The median height would be the 29th person. The height of the 29th person, 147 centimeters. Man, you guys are killing it. All right, let's move on. Percentile. You're going to be asked, what's the 80th percentile? How many people are in the 80th or more? Or how many people are less than the 80th percentile, right? So what percentiles mean is it takes the total and breaks it up into percentages, right? So if you are in the top 10% of your class, you're in the 90th percentile. That's how this works. So if you scored a 67 on a test and you were in the 90th percentile, that means you scored better than 90% of students. You're in the top 10%. So let's take a look at this. What's the 80th percentile, right? Now this is really asking you for the height. It's not asking you for the frequency, right? But you take the total frequency, which is 58, and then, well, that's going to be the 46th, right? So you're going to go 46.4 on your graph. And then you're going to figure out, well, what is the height of that? So the 80th percentile height would be about 159 centimeters tall. So if you were in this group of 58 people, and you were 159 centimeters tall, you'd be in the 80th percentile, which means you're taller than about 80%. You're in the top 20%. Do you see? Now, what if it asked you? Well, how many people in this group of this 58, how many people are below the 80th percentile? Well, that would be 46, approximately, right? And if you ask how many people are taller, well, that would be about 12, right? You're going to have a range of answers depending on how your graph is drawn, because these are going to be hand-drawn graphs most of the time, and you're going to be asked these kinds of questions. But if it was printed like this is exactly what you would do. You'd say, well, from 46 to 58, it's about 12, right? 11.6. So that's how you're going to answer those kinds of questions right there. All right, let's move on. Second to last topic, interquartile range. Inter means in between. Quartile or quarters. We have 4 quarters, right? First, second, third, fourth. The second quarter is the median, 50%, right? Range is the distance. So interquartile range is saying, what is the interquartile range of these heights? So what is the different distance between the 25th percentile and the 75th percentile? So what you're going to do to figure out the interquartile range is you figure out what are each quartile, right? And then you take the difference. Now, the reason this is useful is because if the heights are outside of that interquartile range, they can be considered outliers. There's very few people that are above the 75th and very few people that are below the 25th. Most people, the average, will usually be somewhere in between, right? Okay, so let's talk about how to find the interquartile range. The first quartile is going to be 14.5 because a quarter of 58 is 14.5. The third quartile is going to be 43.5. I almost got my merds mixed up right there. Got them backwards, right? I said 34. 43. Mari, forgive me. Nuyo Madaiween. So, mixing my merds up there on purpose. So, anyway, third quartile is 75% of the total frequency. First quartile, 25% of the total frequency. And then you use those frequencies to figure out the difference in the classes. So, the first quartile, right, the 25th percentile would be 141 centimeters. So if you're 141 centimeters tall, you're in the 25th quartile. You're 25%, right? 25% of people would be shorter than you, right? And then if you're in the 75th percentile, then if you're in the 25th, getting all my numbers mixed up. Let me back up. Let me slow down here. So look, if you're in the third quartile, that's the 75th percentile, right? That means that you are taller than 75% of people. That would make you 155 centimeters tall. If you're in the first quartile, well, you're taller than a quarter of people, which would make you 141 centimeters tall. The range is the difference between those two. It's going to be 14. The difference between 141 and 155 is 14. So the interquartile range, you take your first quartile, you take 25% of your total frequency, and you figure out what is the class that gives us that frequency, right? What frequency would give us that class? So you take the 25% of the total frequency and you use your graph to figure out what the class would be. You take 75% of the total frequency and you use your graph to figure out that, and then you take the difference between the two of them. That's it right there. Boom, done. All right, last one. If you were given a cumulative frequency graph and asked to fill out a table, could you do it? Well, let's do this. First thing I would do is I'd figure out what the classes are. The reason I know what the classes are is because they have these points here. Everything on the curve is an estimation, but those points are going to be known values. So our classes are going to be from 0 to 10,000, and then from 10,000 to 15,000, and then from 15 to 20, from 20 to 25, and then from 25 to 30,000, and these are pounds that are being spent, right? So those are our classes. We don't actually know how these inequalities are defined right here, so we're just going to assume that, right? So we could say from 0 to 10,000. Usually it's this way. Usually this is a less than or equal to, and this one is a strict inequality. We don't really know, but that's good enough, right? Now, what we want to do is we can start filling this chart out from the beginning or from the end and work backwards. It doesn't really matter. I don't think one way is easier than the other. I'm going to start from the end. I'm going to start with the total frequency, which looks like 48. And the reason I know the total frequency is 48 is because it's right here. You can look over, that's 48. So the total frequency is 48. That means that there are 48 people who would, I'm assuming this is people, 48 people that would have spent 30,000 or fewer pounds. That's according to the graph, right? Now, if I want to figure out how many people are actually between 25 and 30, well, I got to look at that 25. At 25,000 people, what's the total frequency at 25,000? So it tells me that there are 44 people. I looked over here. There are 44 people who spent up to 25,000. So 25,000 or less, 44 people. Now, 48 people spent more than that. So that would be from 44 to 48. Well, that's just a difference of 4. There were 4 people that spent more than 25,000 but less than 30. And so you're going to repeat that process for the whole thing. So look, right here, I know that the cumulative frequency up to 25,000 was 44. If I want to figure out the frequency from 20 to 25, though, I need to figure out what is the data point right here. So that's 20,000. And if I follow this over, there were 34 people that spent 20,000 or less. There were 10 people that spent between 20,000 and 25,000. That's how I know that there's 10. And you just repeat that process. So 34 people, that's the cumulative frequency up to 20,000. At 15,000, there were 20 people. So there's a difference of 14 people. There were 14 people that spent more than 15, less than 20. And you can just continue that. At 10,000 people, at 10,000 pounds, there were 8 people. So that's a difference of 12. And 8 people spent up to $10,000. So $10,000 or less, 8 people. I know that's a lot of information. Man, it's a topic that is both easy and difficult. Like I said, none of the concepts are hard. None of the calculations are hard. The number one thing people mess up is they forget what cumulative frequency is, and then they mix up which of the axes is cumulative frequency and which one is the classes. So I hope it's been helpful. Man, it's going to take some practice, but you guys can handle this. Hope this helps you out. Take some good notes, review back to it if you need, and man, talk to you guys soon.